So now let's make it a little bit more complicated. So this would be example 2. So this is example 2. Okay. So first thing is I'd look at this and say, uh-oh, this guy's going to factor. So the simplified factored form, because see, I need the factors to be able to find all these zeros. So that would be what? X plus 6, X minus 5. So my simplified factored form. Then once again, my vertical asymptotes are the zeros of the denominator. So X plus 6 equals 0, X minus 5 equals 0, X equals negative 6, X equals 5. So remember, for vertical asymptotes, they're just vertical lines. So it's X by itself. So X equals negative 6, X equals 5. So if you wanted to, you could go over here and graph it already. So you could say, okay, so I've got a vertical asymptote at negative 6. And I get a vertical asymptote at positive 5. So already I'm thinking, uh-oh, this one's going to be a lot more difficult. Horizontal asymptote. Well, same situation here. The degree of the numerator is an understood 1. So 1 over 2, the degree of the numerator is less than the degree of the denominator. Therefore, the horizontal asymptote is y equals 0. So we have y equals 0. Remember, the horizontal asymptote is always just y by itself. And once again, if it has a horizontal, it will not have a slant. These guys has a horizontal, no slant. The x-intercept are the zeros of the numerator again. So let me see, x is equal to 2. Remember, x-intercept we do as a point, so 2 comma 0. And then somebody yells at me and says, wait a second, that's on the horizontal asymptote. I know it happens sometimes with horizontal asymptotes or slant asymptotes. Sometimes you intersect them, but it's always inside the graph. It's always on the inside of the graph. You never intersect them way out here when you're going to infinity. It's always just kind of inside the graph. The y-intercept is when what I was about to say. The y-intercept is when you put 0 in for all the x's. So if I put 0 in for all the x's, so that would be 1/15th. So remember, the y-intercept is when x is 0 and negative 2 over. So 1 over 15. What the heck? That's kind of weird looking, but it's right down here, and you're the, I don't know. Of course, you can't draw that perfectly. We don't expect you to draw it perfectly. Okay. All right. Point of intersection. Here we go. Point of intersection. Do we intersect the horizontal asymptote? So we have to take the original function and set it equal to our horizontal asymptote, which in this case is 0. So this is to find the point of intersection. So now we got to solve this problem. So in this case, we can cross multiply. So we can say x minus 2 is equal to 0. So x is equal to 2. And somebody says, oh, wait a second, duh. Because the x-intercept, we already knew. See, x is equal to 2. So the x-coordinate of the point of intersection is 2. Then you plug the 2 back into the original function. So we plug the 2 back into the original function. Whoops. 2 squared plus 2 minus 30. Well, see, I don't even care what the denominator is. I don't even care that the denominator is, because the numerator goes to 0. So we know that the point of intersection is 2 comma 0. We knew that the y coordinate was going to be 0 anyway, because all the y coordinates of the asymptote are 0. Okay. Was there any factoring? Factoring. Let me see. We factored. We did factor, didn't we? We did factor, but did anybody cancel? Nobody canceled. So there is no hole in the graph. Whoops. There is no hole in the graph. Okay. We got to graph it to do the domain and range. Or normally that's what I would say. We have to graph it to do the domain and range. So right now, this is all we got. I got these points. And somebody says, oh no, how am I going to finish this? All right, we can finish it a lot of different ways. For one thing, I know that these guys have to connect. Those guys are going to connect. So now the question is this piece right here going to curve up next to the asymptote forever, or is it going to turn and come back down? Because this is what we're going to do when we get to class. And I say, well, what is it going to do? Can it turn back down? And the answer is no, it cannot turn back down because it cannot cross the x-axis again. I know that there are no other x-intercepts. I know that there's no other x-intercepts, and I know that it only touches the horizontal asymptote. It only has that one point of intersection. So in my brain, I know, oh, wait a second, it cannot turn back down. So the only thing it can do is go back up. Somebody says, oh, convince me. All right, let's do -5. If I plug -5 in there, so let's go back to our T-chart. So if I plug -5 into the original function, so this is going to be a real pain in the drain here. So that's going to be -7 over 1 times negative 25, positive 25. Something's wrong. If I plug -5 in there, that's -7, -10. What am I doing? -7 over -10. -7 over -10. So 7/10. So 7/10 would be like here, and you're thinking that looks really weird. But it actually fits what we're doing, because 7/10 is higher. 7/10 is higher than 1/15. So it does start to curve up, and then it's just going to have to curve and run alongside the asymptote like that. There's no place else for it to go. You know, it can't curve back down. So if I wanted to, I could plug in some more points like -5.5, -5. Okay, so I cheated here just to prove it to you. So I put it on the calculator because these are just a hassle. So if I did -5.9, if I did -5.9, the y value is 7.2. So -5.9 would be about right here, but the y value is 7 point something, so it's way up here. So just to convince you that as x is getting closer and closer to -6, those y values are getting bigger and bigger. So they would be increasing up to infinity like that. Anyway, that was lazy of me, but we're not going to expect you to do a T-chart necessarily and do all these points. You just need to remember the pattern. And then, like, what's happening over here? Does it bounce and curve back up, or does it come on down? Well, let's find out. Let's put a point in there. Let's do 4. So if I plug 4 in here, that makes 2 over 8 times -1, which is what? -1 over 4, -1/4. So if I plug 4 in there, I get -1/4. Oh, it went down here like this, which means the curve has to be coming down like this. Okay. So once we establish, you say, well, how do you know it doesn't turn and come back up? Well, there's no other points of intersection. It can't curve and come back up. Then I'm going to get really lazy right here. So what's happening out here? I know I can't cross the asymptote. Is it above or below the axis? Well, let's just do a test point. Let's do 6. So if I plug 6 in there, that would be 4 over 12 times 1. So 1/3. So if I plug 6 in there, I get 1/3. Oh, it's above the axis. So that means the entire curve must just be running alongside the asymptotes like this. And if you wanted to do a whole bunch of points, you could do that and prove it to yourself. Let's do -1/7. If I plug -1/7 in, -7 there, I get -9 over -1 times -12. So what is that? 3/4, -3/4. So that's negative. Whoops, I'm sorry. Oh, those are both negative. So that's -9 over +12. So -3/4. So when I plug -7 in there, I got -3/4. Key thing being it's below the axis. It's below the axis, so the entire curve has to be below the axis, and it has to be in here just running alongside the asymptotes. So once again, we can ask you the domain, because as I move from left to right, I have to exclude the vertical asymptotes. So I know this is a hassle to write, but you have to exclude the vertical asymptotes. And in this case, this would also be a fair question to ask you the range on, because if you say, well, it doesn't, like I went up and then I have to stop. But if you look in the middle part, you're going up, 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 up. You do touch the horizontal asymptote, and then you continue on up. So just the middle part right there, the middle part of the curve is -infinity to infinity. Okay, so a little bit more complicated, but not killer complicated. They'll get worse. Don't worry. We'll continue.